You'll get them. All right. You're looking at lesson 72 today. We've done experimental data. They're the ones where you have a graph and there are dots on there, and the dots all have circles around them. You remember those? Yeah, and you estimate the slope as best you can. Okay. Now they give you the data. You don't have to copy the graph, but they give you the data. Is there a line on here? No. We got to make our line now. Does that make sense? Is it the same thing as what we've been doing before? Now you just have to draw the line. That's right. You're still going to do the exact same thing. You just have to make your own line. Yeah, you're looking at the line of best fit. Yeah. So we are going to estimate the line that the data points represent. Depending on how you see the data, your line of best fit will look different. So someone, like, right? That is terrible. Yeah. Someone go draw what they think is the line of best fit. It has to be a straight line. Yes, it has to be a straight line.
Are you connecting those like dots right there?
Right there. Okay. Does someone else see a different line of best fit?
You got like two lines.
Those lines are like always.
Excuse me. Okay.
Watch.
It's gonna.
Oh my god. Okay, here's draw it slowly. It might not be like as straight, but it'll be slower.
Okay, she says do something like that. Does anyone else see a different line of best fit?
That's what I'm saying. I would keep it like on those dots in the middle of those.
Okay, well if you look at the book, page 290, they have two different lines of best fits, depending on how you see it. Paige, you're probably going to have to pull this up in a textbook. Page 290, I don't know if you can, I doubt you can see this. I don't know why it's green. I don't know. Who knows? Anyway, this is the data points, and do you see how they have the same one basically that you have? And then they also have this one. Or you might have it, yeah, you might have it turned more like this, like in between the two of them. Do you see how there are different lines that you can draw depending on what you're looking at? Okay. Yeah, you only have to pick one, and your answer will end up being close to what they have. You want to have them in decimals so that you can see how far off you are. If your slope is close, that's a good thing. If your slope is way off, that's not a good thing. Does that make sense? It just depends on, yeah, it depends on the numbers. If you're looking at like a slope of 100 to 110, that's really not a big difference. But if you're looking at a slope of 40 to 60, that's a bigger difference. Does that make sense? If you're looking at like from 100 to 110, that's not as big of a difference. Oh, no. No. Does that make sense? But if you've got, like, if your slope is 3 and theirs is 0.02, that's probably not going to be right. Does that make sense? Your slope should be close, but if your slope is off, your B is definitely going to be off, okay? So these, you're probably not going to have the same answer as what's in the answer key, but that's just what they got as their line of best fit. No? You're just going to have to, like, put it on your test, on your, what is this? Textbook. On your textbook. Put a piece of paper and like make a little line, or use a ruler or your ID or something, and just look at it and pick 2 points based on that. Does that make sense? All right. Okay, so once you have your line of best fit, do you do anything different? Like once you actually draw your line. Okay, so all we're doing on these, you just have to add your line. Yes. I made that one. They're not. They'll still be circled. It's saying that they're data points. That's all. Yeah. It takes too long. Any questions on this? Do y'all understand how you would make your line a best fit? So your answer should be close, but it won't be the same. It depends on your exact line of best fit. So I'll look at your graph, and that's why you need to put your 2 points that you picked so that I can see, yeah, those are on your line that you picked, or those are not even on your line that you drew. Does that make sense? Just like you've been doing, you have your 2 points and then go from there. Any questions on this? Okay, so that's all dealing with the line of best fit. You just now have to draw your line and then do the exact same thing as what you've done before. This 5 at 37 degrees, we've drawn these before, right? Negative angles. And then what we haven't done before is 5 at negative 323 degrees. We haven't had negative angles yet. Yeah, you can have a negative angle.
Go back.
For this one, will someone go draw what it looks like? No, you've already been to the board. No, you've already been to the board.
Sean's going to the board.
What's this? Is it new?
Do you agree? Which way did he go from the x-axis? Counterclockwise, right? This is counterclockwise. Okay. All right, looking at this one. It's a negative, so which direction are we going to go? We're going to go clockwise. We're going to go down from the x-axis. So, am I going to stop yet? In this quadrant? Is that about 323 degrees?
Wait, why are you always have to do the first quadrant?
That's what it told us. Negative 323. So I went down 323 degrees, right?
Yep.
So what angle is right here? 360 minus 323, which is 37 degrees. Same thing?
Yep.
They're the same exact thing. There are two different ways to notate them, depending on if you go positively or if you go negatively. Does that make sense? Where did I draw my triangle? Where, no, to the x-axis or to the y-axis? Always to the x-axis. You can get it right. It's a lot easier if you do it to the x-axis.
I always do that. I used to do that.
Any questions on how these two work? Okay, so we're actually going to look at an example, and we're going to write it in rectangular coordinates. We've got 4 at negative 210 degrees. Yeah, the R and the U. So first, just see if you can draw it in the correct quadrant. Alright, someone go draw what it looks like.
It's not 150. I said that too. It's not. It's 30 minus 30.
Oh, 30. Oh, I understand.
You remember what I was saying now?
Yeah, it's 30.
Do you agree with that? How do you get the 30 degrees? We went 210 degrees, right? But what is it to here? So how much further did we have to go? 30 degrees. Does that make sense? Okay, so which one is my R, which one is my U?
R is the x-axis, and then U.
Okay, how would you find your R? So what does R equal? Say it. What'd you? Oh, 30, not 20. Yeah. Does that make sense? What do you get for R? You get 2. Okay.
Oh, wait, no, cosine is...
Cosine is 3.464.
Okay. There we go. Look at yeah. Yeah, R is yeah.
And it's bigger. It's bigger.
Well, yeah, we'll get to the negative part. But yeah, that's R. All right. So how did you find U?
Yeah, what? No. 4 sine. No,
Oh, okay.
4 sine.
Does that make sense? All right. So R. Which way are we going for R? So is it positive or negative? All right. So negative 3.46. Yeah. And then U. Are we going up or down? So positive or negative? Do you see how that works? Any questions on that part? The cosine is adjacent over hypotenuse. R over 4. If you draw it to the x-axis, that's true. If you don't draw it to the x-axis, then that's not true. But yeah. Yeah. Yes. That is true. Any questions here?
No.
Okay, go ahead and clear your desk for your test corrections in.